Here in video 26, we're going to show how the longest flow line, which impacts travel time and rainfall intensity by extension, the longest flow line can be edited, and once edited, it locks in, and the edits are retained, both in terms of liner material or lengths of any individual component. So let's review this. We're going to bring up Precision3D, and you can see we've done a calculation with the following settings. 50-year storm, we've divided our channel into 3 segments, and we have a 100 and 300 foot sheet and shallow concentrated flow. We're using TR55 kinematic wave as the derivation of the travel time. This has led, in this particular watershed, to a travel time of concentration, of 7.226 minutes. Now, you have flexibility if you've done no edits of the actual channel, of the actual flow line. You have the flexibility to rerun it at a different number of channels. Right now, we have, if we pick on it, we have 3 channel segments, one from here to here, which is implausible because this would be a continuation of sheet flow. So we want to do an eventual edit there. One all the way down the uniform roadside ditch, and then one final segment into the lowest point. And the program, when you select a number of segments, finds the 3 most uniform, distinct segments. And that's what it has found here. But if you wanted to, say, capture this particular segment, known to have a 0.09% slope, very flat slope, to illustrate the impacts of that, all of our channel liners are class 3 or 4, referring to riprap size of 9 and even 12 inches. Let's see what the effect is if we change to 6 segments. Well, to do that, you go and slide down to the number of channel segments and change it to 6. It'll find the 6 most distinct segments and run the storm event again. We'll pause while it's calculating. As we resume, we note that the time of concentration has gotten longer. The travel time has gotten longer. It's now 8.138 minutes. You can see that there, right on the right there. And part of the cause of that is we have isolated this segment with such a low slope of 0.09% that this segment alone has added to our travel time and thereby reduced our peak flow. So it has an actual effect identifying more segments. But note also that that segment, which looks to be the second to the last, so probably it's segment 5 of the 6, actually is a grass lining segment. So the program runs through the liner materials in the order they are given in this table at left, and if it can make grass lining work, it will. Then it moves on to 2, 3, 4, and finally the 1A channel lining, which can handle up to 35 pounds per square foot of shear force. Now, if you look at the grass lining, the maximum it can take typically is 1 pound per square foot, and it calculates out to, in this case, on number 5, a permissible, an average shear stress of only 0.174. And we have defined this very carefully using a particular cross-section. And our current cross-section is the one shown here. If we make any change here on that channel by redefining the cross-section, we should go with a trapezoidal, then the channel aspects of it lock. Let's illustrate that here. We're going to continue the shallow concentrated flow all the way into the ditch here and slide this segment down and put this segment right in the ditch and pull this all the way around and into the front of that ditch. And now, if we just touch on the shallow concentrated flow line, it turns and extends. And if you look at its values here, we've extended it from the default 300 to 389 feet. Now, when we run the calculation, that edit has caused this channel to be locked. It's not going to change the shallow concentrated flow length. It's going to put all the channel portions into actual channels and consider a longer sheet flow in the process. We'll pause. At this point, if you highlight the channel, you are no longer able to alter the number of segments, but you can, for example, on segment 5 here, select the shape, choose the actual shape of the channel at this location, which is a 10-foot bottom width trapezoidal channel, and with that added precision, go ahead and select the storm, recalculate, and then watch for its effect on the time of concentration and peak flow. Each segment can be edited according to its actual cross-sectional characteristics.